Welcome to Introduction to Net, Surface Area, and Volume. By the end of this lesson, you will be able to create a net for a prism, define surface area, and define volume. Now, before we start talking about nets, you need to know what a prism is. A prism is a three-dimensional shape with a top and a base that are congruent polygons. That's important. So if we look at our examples, the first is a triangular prism. Notice that the top and the bottom are congruent triangles, or the top and the base. The next is a square prism. So the top and the bottom are congruent squares. The next is a pentagonal prism. So the top and the base are congruent pentagons. And last, the hexagonal prism has a top and a base that are congruent hexagons. Now, all the other sides in these prisms are parallelograms, or four-sided figures with parallel and congruent sides. So the lateral faces, or the other sides of a prism, are parallelograms. Notice that each prism is named for the shape of its base. So, for example, what you usually think of as a box is called a rectangular prism. Now you have a lot of different boxes laying around your house. If you were to unfold one of those boxes, you would get the pattern that the manufacturer cut out before they put the box together. That pattern is called a net. A net is a two-dimensional pattern that can be folded into a three-dimensional figure. So this net would be folded up into a cube. So it is the net of a cube. Now we could rotate this net around and it will still create the same three-dimensional figure. So we can manipulate it to make it look a little different. So there are many different ways to draw the same net for a three-dimensional figure. Here we have a net for a rectangular prism. In this case, it's for a package, so they created little tabs. In a normal net, we wouldn't have the tabs. But here you'll see how when you fold up the net, it forms the rectangular prism. Here's a triangular prism. When you fold up the net, it creates a triangular prism. So now that you know what a net is, what three-dimensional shape is this net? If you said a rectangular prism, you would be correct. Notice that these would form the base and the top of the rectangular prism. These other four rectangles would form the other four sides. Two of those rectangles are congruent rectangles, and the other two are congruent rectangles. So altogether, you have three sets of congruent rectangles, forming 6 total rectangles. Now you'll want to keep that in mind when we talk about surface area. Before we talk about surface area, I want to refresh your memory on how to find the area of a rectangle. To find the area of a rectangle, you multiply the length of the rectangle by the width of the rectangle. So area equals length times width. So for example, if you wanted to find the amount of paper that would be needed to cover this rectangular tabletop that has a length of 12 feet and a width of 4 feet, you would multiply 12 feet, the length, by 4 feet, the width, to get a total area of 48 square feet. What that tells us is 48 square units would be required to cover the top of this table. Now, area is directly related to surface area. Area determines how much it takes to cover a two-dimensional figure. Surface area is the total area of the surface of a three-dimensional object. In other words, it's the number of square units it would take to cover a three-dimensional object. So we could count up the number of squares that it takes to cover this whole cube. So notice just one face of this cube is 16 square units. We would need to figure out how many square units it takes to cover the whole entire cube. The key word here is cover. So when you think of surface area, you should think, how much does it take to cover it? Volume is the amount of space that a three-dimensional object occupies. So it's the number of cubic units it would take to fill a three-dimensional object. So, in other words, you want to figure out how many of these cubes it would take to fill this rectangular prism. Now, your first assignment is to think a little bit more about surface area and volume, in particular of a rectangular prism, and explore the other links I have posted on the main page. Then come up with a real-life situation or example of a time when you would need to find the surface area and volume of a rectangular prism. Once you come up with a real-life situation or example, I want you to explain the steps you would follow to find the surface area and volume of that rectangular prism. You do not need to have exact measurements or give exact calculations, just an explanation of the steps you would follow. Please let me know if you need any more clarification on the discussion board post assignment, and email me if you have any other questions.